Okay, in this chapter we're talking about the Pythagorean theorem. If you look on your Canvas page, I've given you a diagram of the Pythagorean theorem that would be beneficial to your students when you get into teaching, especially for those of you who will be teaching like 5th or 6th grade. So you'll see the Pythagorean theorem there, and you might teach it in those courses. So first of all, you'll use the Pythagorean theorem to figure out the length of the legs and hypotenuse in a right triangle. So first of all, it has to be a right triangle, which means that it has to have a 90-degree angle. So a right triangle has 3 parts. It has a leg, and then it has something called the hypotenuse. So what's special about the hypotenuse is it's always opposite the right angle. So it doesn't touch the right angle. 2 legs make up the right angle, and across from that is the hypotenuse. So the hypotenuse says c squared equals a squared plus b squared. Now, I've seen some proofs of these before, especially with graph paper. So if you're one of those hands-on math teachers and math is your thing, and you're teaching this in the upper elementary grades, I could see a big use for this, because you can show the diagram, especially if you made these into squares, like graph paper squares. You can show that why this is c squared, literally, and it'll have that many blocks in it. So it's really cool, and you can find some applications on that on YouTube. And probably the video that I put in the bottom of your Canvas lesson in the hint section. The sum of the areas of the squares on the leg of a right triangle, that sum is equal to the area of the square on the hypotenuse. All right, so in the first one, just getting straight down to business, I'm going to ask you, let me put some values up there. I'm going to ask you to find, this is 9, and this is 12, and this is x. Okay, so I'm asking you to find x. Well, so we have to find where the right triangle is first. Sorry, right angle is first, and that's where it is. So this side right here would be my c. Okay, so in this case, c is the x value. Now, as far as the legs go, it does not matter which leg is 9 and which leg is 12. It doesn't matter. So if you said 12 squared plus 9 squared, it's the same thing. It doesn't matter which order you put them in. Now, as I'm doing this, I get out my fancy little calculator, right? I'm so glad we get to use a calculator in this class. It makes it a lot easier. So if I put 9 squared in my calculator, of course I get 81. And if I put 12 squared in my calculator, I get 144. I actually did know those, but 81 plus 144 would give me 225. Now, you'll have to forgive me. This board that I'm using today to make the video, it's getting old, and so it makes little marks like this a lot. So please forgive me. There's unfortunately nothing I can do about it at this time. So let's see if we can write it a little bit neater over here. So I get the equation that x squared equals 225. So to get x by itself, I can just take the square root of both sides. And the square root of 225 is 15, I believe. Yep. And so in this particular problem, x is 15, and that's your hypotenuse. The hypotenuse is always going to be longer than your sides. Okay, so let's try another one of those. Let's use, I use that sheet. Let me get my second one. Okay, so that's what this one looks like. So in this particular case, the c is the 25. Okay, so that's going to be 25 squared equals 15 squared plus x squared. Okay, so 25 squared, I think is 625, but let's double check it. 625. 15 squared is 225 plus x squared. Okay, so to solve this out, I'll move the 225 to the other side, and I get that 400 equals x squared. Okay, since we're talking about geometry and we're talking about measurement, your sides of a triangle can only be positive. So we don't have to worry about taking the positive and negative square root like you would do in your algebra class. So all you have to do is take the square root to find your value. And the square root of 400 is, so let's remember the board's a little messy. So 20 would equal x, and that would be your missing side length. All right, so those are your basic Pythagorean theorem. I gave you one where you're finding the hypotenuse and one where you're finding the leg. So then they give you some in the Access Pearson homework that would be a little bit tougher. So it says if one leg, let's go ahead and draw up our rough sketch of a triangle. If one leg is 4 times the other leg and the hypotenuse is 17, find the area of a triangle. Okay, so that's pretty important there. I'll scoot this over. And it's very tricky because this time I'm not finding the leg, I'm not finding x, I'm finding the area of a triangle. So make sure you pay very close attention. The other thing I want you to pay close attention to is in the Access Pearson homework, it wants you to leave it in simplified radical form. So you want to simplify the radicals the best you can, but you don't want to make it into a decimal. So I'm going to call this leg x. It doesn't matter which one you called x. One leg is 4 times the other. So this leg means that it's going to be 4 times the other, even though it's not drawn to scale. And this is 17, because that's the hypotenuse. All right, so the first thing I need to do is find these two leg lengths. So it says c squared equals a squared plus b squared. Okay, so c squared 17 squared equals a, which I'll call x, plus b squared. Okay, so 17 squared is 289. I'm going to double check that in just a second. Equals x squared plus 16x squared, because 4 squared x squared. I'm pretty sure that's correct for the 17, but let's try it anyway. Yep. Okay, so when we add, we got our 289, right? And that's going to equal 17x squared. Okay, so I'll divide both sides by 17. 289 divided by 17 would be 17 equals x squared. So to find the value of x, we're going to take the square root of both sides. So the square root of 17 would equal x. Now remember, this particular assignment in my math lab or Access Pearson homework asks you to leave it as a radical. Okay, so that means that this side right here is x. So this side would be square root of 17. And this side is 4 times x. So this side would be 4 on the square root of 17. Now those are the measures of the triangle. The question asks you to find the area of a triangle. So the area formula of a triangle is 1/2 the base times the height. Okay, so the base of the triangle is this side right here, which would be 4 on the square root of 17. And the height of the triangle would be this side right here, which is the square root of 17. Okay? So when we multiply it out, we have 1/2 times 4. And remember, when you multiply radicals, well, some of you know these would cancel out and give you a 17. But you can also say that you'll multiply on the inside. So if we clean that up, we're going to get 1/2 times 4. The square root of 289 would be 17. And so this would be 34 centimeters squared. Okay, and so that's how that one would look. Now, talking about the units of measure, area is measured in square units. So it's going to ask you that in some of the Access Pearson homework, area is measured in square units. In this case, it would be square centimeters. All right, I think we have a couple more of these to do. This one wants you to find the area of the parallelogram. Okay, so let me put the values in there. There we go. Okay, this value it's given you is 10, and this value is 18, and this value is 6. And it asks for the area of a parallelogram. Okay, so remember the area of a parallelogram is base times height. Okay, it's also length times width. If you wanted to, nope, it's not length times width. Scratch that, I said that. That's the rectangle. So the area of a parallelogram is base times height. Okay, this is the height. So before I can find this area, I have to find this little length. Well, what I notice about this red length is it's a leg. So c squared is going to equal a squared plus b squared. C is the hypotenuse, which is 10. Okay, 10 squared is 100. 6 squared is 36. I'm going to move the 36 over. So 64 would equal b squared. And take the square root of both sides, and 8 would equal b. Okay, my height is 8. Now, so that's great. So I'm going to have area. Sorry, let me fix that color really fast. Area equals base times height. Okay, so I'm part of the way. Now, the base of this parallelogram, it's a parallelogram. The base of this parallelogram is this distance right here. Well, what I know about a parallelogram here is that they have the opposite sides are equal. So if that top one is 18, that means the bottom one is 18 as well. Okay, if I put that in my calculator, I'm going to get 18 times 8, which would be 144. Okay, so this one didn't give you units. So I just want to, the ones on your homework will give you units. That was my error for not giving you units there. But remember that whatever units it would be, they're going to be square units. Okay, so you might write units like that, a square unit with the SQ for square. But let's say it was meters. Then you can also write them like that as meters squared if it was meters. Just know that it's going to be square units because they're going to ask you that in the Access Pearson homework. All right, so then in this one, the values that are given, this is 60, and this is 70, and this is 70. Okay, and that's what's going to be given to you. This is the area of a triangle. So remember the area of a triangle is 1/2 base times height. Okay, well the good thing about this one is I already have the height. That's the height right there. So this is going to be 1/2 base times the height. Okay? Now I just have to find the base. So I'm going to take this little triangle right here, just this one. If I take that red triangle, this is 60 and this is 70. It's a right triangle, right? So this is c squared equals a squared plus b squared. C is the 70. So this would be 4,900. This would be 3,600. Going to move this over. Okay, and I'm going to take the square root of it. Now, this is where this one gets interesting. I think there's one like this in your Access Pearson homework. That's the reason I picked it. So what's special about it is the directions say make sure you keep it in exact form. Keep the radical in there if necessary. So if you tell me that the square root of 1,300, let me put it in there, is 36.05, that is correct, but that's not what they want it like. So what you have to do in this particular case is remember from college algebra how to break this down. Okay, so if you're simplifying the square root of 1,300, I know that the square value that goes into that is 100. So that's 100 times 13. And the square root of 100 would be 10 on the outside and 13 on the inside. So that means this little piece right here is 10 on the square root of 13. So that also means that this little orange piece right here, since they match, is also 10 on the square root of 13. So if you add those up, what are you going to get if you go all the way across? Is you're going to get 20 on the square root of 13. And that is your base. You'll say, now why can't we write it as the square root of 1300 is 36? Well, that would be fine with me, but unfortunately that's not what the computer program is willing to accept. All right, so let me finish this one up. Okay, so now then I get 1/2 times 20 times 60. So 1/2 times 20 times 60 would be 600, I believe, on the square root of 13. Again, I didn't give you units of this, and I probably should have, so just know that when you're picking your answer, you're picking square units. And like I said, they're going to want it in traditional radical form, exact radical form, so that's how they're going to want their answer to look. I know this part right here is a little complicated, but that's how they're wanting it. Last one, and these are the easiest ones. They're just giving you 3 sides of a triangle, and they want you to see if it can be a right triangle or not. All the right triangles have to work with the Pythagorean theorem. Remember also, we'll do this one green, remember also that if you have the Pythagorean theorem, the hypotenuse has to be the longest side. So let's check this first one. Right. Okay, so my longest side is 29. So if this is a right triangle, this equation is going to be true. Okay, and this is when the calculators are very useful. 29 squared is 841. 18 squared is 324. And 22 squared is 484. If I add up 484 and 324, I get 808. Okay, these do not match, so this is not a right triangle. Okay, so let's do this one, and let's do this one in orange. Okay, c squared would equal a squared plus b squared. My longest side is 34. Okay, let the calculator do the work. If I add up 900 and 256, I get 1156. Okay, so this one matches. So c squared does equal a squared plus b squared, so that means that this one is a right triangle.